Section 1.5 is titled Dividing Integers. So for the standard 7C4, understand that integers can be divided provided that the divisor is not 0 and that every quotient of integers is a rational number. And we'll also learn the rules regarding signs and understand where the placement of the negative sign goes in a rational number. So the first step to dividing integers is dealing with signs. So you need to make sure you're writing this in your notes, but the quotient of two integers with different signs is negative, and the rules for the signing with division are the same for multiplication. So if we have an integer divided by a negative integer, that answer would be negative. If we have a negative integer divided by a positive integer, that answer is also negative. So in the examples, you can see two different problems that both give the same answer. 10 divided by negative 5 and negative 10 divided by 5. Both give negative 2. So here are some examples that I'd like you to work out. We have negative 35 divided by 7, so you just do the division like normal. 35 divided by 7 is 5, but our answer should be negative. We have 64 divided by negative 8. So again, that's positive divided by a negative, so we get negative 8. 63 divided by negative 7, so positive divided by a negative is a negative, negative 9. And negative 110 divided by 10. So negative divided by a positive, that's again going to be negative. And if you know your rules with the zeros, you could just knock a 0 off, and you would see the answer is 11. Next, we have the rules for dividing two integers with the same signs. So the quotient of two integers, remember quotient means the answer to a division problem. The quotient of two integers with the same signs is always positive. So for example, a divided by b, that's a positive integer divided by another positive integer, you would get positive a over b. And in the second example, a negative a divided by a negative b, you would still get positive a over b. And in the examples, again, two different problems with the same answer. 10 divided by 5 is 2, and negative 10 divided by negative 5 is also 2. So here are some more examples. 48 divided by 12, hopefully you know your multiplication facts through 12, and that's positive 4. Negative 56 divided by negative 8 is 7, positive 7. Negative 35 divided by negative 5 is also positive 7. And 39 divided by 3, if you're not sure how many times 3 goes into 39, you can do some long division. 3 goes into 3 once. Then we multiply 1 times 3, subtract, bring down the 9. 3 goes into 9 3 times, so remainder 0. So it's positive 13. Let's evaluate the expression. We're told that x equals negative 6 and y equals negative 3. So we want to remember our order of operations here. First, I like to just see you plug in the numbers for the variables to show me that you can do correct substitution. So we have 12 times negative 3 divided by negative 6. Remember that multiplication is not more important than division, but here it just happens to come first. So 12 times negative 3, multiplication rules from the previous day. If we have a positive and a negative, our answer is negative. So we get negative 36. Now we're dividing that by negative 6. So a negative divided by a negative is positive, and 36 divided by 6 is 6. In number 10, likes to substitute those values in first. So on top, we're plugging in a -6 for x, and in the bottom, you're plugging in a -3. And here we have a fraction. Remember that a fraction is division, and in the numerator, we have a multiplication problem. So we do need to take care of that multiplication first, so that we can then divide by -3. So on top, -5 times -6 is positive 30, and we're dividing by a -3. 30 divided by 3 is 10, but because it's a positive divided by a negative, our answer is -10. In class, we'll work on worksheet 1-5.